You've stood at the bottom of a mountain and felt small. You've stood at the edge of an ocean and felt the same thing. Maybe you've looked up on a clear night, away from city lights, and felt it most of all. That strange mix of wonder and insignificance. But here's the truth. Nothing you have ever seen with your own eyes has prepared you for what we're about to explore. Not the mountain, not the ocean, not even the night sky itself, because almost everything up there is far closer and far smaller than what lies beyond it. In the next half hour, we're going to leave Earth behind, not metaphorically, but step by step, scale by scale, until the numbers stop making intuitive sense entirely. We'll pass the moon, the sun, the edge of the solar system, the outer arms of our galaxy, and clusters of galaxies so vast that our entire Milky Way becomes a single point of light among trillions of others. By the end, you won't just know how big the universe is. You'll understand why that number is almost impossible for a human brain, built to judge the distance between trees in a forest, to truly hold on to. And you'll understand why that's not a depressing thought, but one of the most beautiful facts we've ever discovered. Let's start where you are right now. Earth is, by any human measure, enormous. It would take you over a year to walk around it without stopping. Its oceans hold more than 1 billion cubic kilometers of water. Everest rises nearly 9 kilometers into the sky. Every war, every love story, every civilization that has ever existed, all of it happened on this one rock. And yet, from space, Earth is a marble. The Apollo astronauts could cover it with their thumb. Voyager 1, looking back from billions of kilometers away, photographed it as a single pale blue dot, less than a pixel, suspended in a sunbeam. If we shrink the sun down to the size of a basketball, Earth becomes a grain of sand, orbiting about 26 meters away. At that scale, the nearest star beyond our sun would be another basketball, over 7,000 kilometers away. That's the first lesson of this video. In space, even the things that feel infinite to us are, in truth, almost unimaginably small. So if Earth, our entire world, every mountain, every ocean, every person who has ever lived, is only a grain of sand on this scale, what does that make everything else? Our solar system feels vast to us. Light from the sun takes 8 minutes to reach Earth. It takes over 4 hours to reach Neptune. A spacecraft traveling at tens of thousands of kilometers per hour needs nearly a decade just to reach the edge of the planets. But the planets are not the edge. Beyond Neptune lies the Kuiper Belt, a vast ring of icy debris and dwarf planets like Pluto. And beyond that lies the Oort cloud, a theoretical shell of icy objects so distant that light from the sun would take roughly a year and a half to reach its outer edge. That means our entire solar system, every planet, every moon, every comet we will ever see fits inside a bubble roughly 2 light-years across. And the nearest star system to our own, Alpha Centauri, is over 4 light-years away. Between us and our closest stellar neighbor lies a gulf of cold, empty space more than twice the width of our entire solar system. And here's the part that should genuinely unsettle you. Our sun is just one of roughly 100 to 400 billion stars in our galaxy. If our solar system is already this incomprehensibly vast, what does that make the structure that contains hundreds of billions of systems just like it? Our galaxy, the Milky Way, is a flattened spiral disk roughly 100,000 light-years across. Light, the fastest thing in the universe, fast enough to circle the Earth 7 times in a single second, would need 100,000 years just to cross it. Our Sun sits in a minor spiral arm, about 26,000 light-years from the galactic center, orbiting that center once every 230 million years. The last time our solar system completed a full orbit, dinosaurs did not yet exist. Within that disk, somewhere between 100 and 400 billion stars, current estimates suggest there may be more planets in our galaxy alone than there are stars, potentially over 1 trillion worlds, many of them in the so-called habitable zone, where liquid water could exist. And the Milky Way isn't even unusually large. It's a fairly typical mid-sized spiral galaxy, which raises an uncomfortable question. If a single, ordinary galaxy can contain hundreds of billions of stars and is so vast that light itself needs 100,000 years to cross it, how many galaxies like ours are actually out there? The Milky Way is not alone. It belongs to a collection of more than 80 galaxies called the Local Group, spread across roughly 10 million light-years of space. Our nearest large neighbor, the Andromeda Galaxy, is over 2.5 million light-years away and is currently on a slow collision course with our own galaxy, due to merge in roughly 4 billion years. But the Local Group is just a small suburb. It belongs to the Virgo supercluster, containing perhaps 100,000 galaxies spanning over 100 million light-years. And the Virgo supercluster itself is just one lobe of an even larger structure, Laniakea, a supercluster of over 100,000 galaxies stretching across roughly 500 million light-years, discovered only in 2014. At this scale, individual galaxies stop mattering. Astronomers studying these structures don't talk about stars or planets anymore. They talk about galaxy clusters as if they were grains of sand, forming vast cosmic filaments and walls, with enormous voids of empty space between them, in a structure scientists call the cosmic web. We have now traveled so far that our own sun, our entire solar system, every star in our night sky, all of it has shrunk to a single point of light, indistinguishable from 100 billion others, inside one galaxy, inside one supercluster, inside a structure so large it took humanity until 2014 to even map it. Here is where things stop making intuitive sense entirely. The universe is approximately 13.8 billion years old. Light from the earliest visible objects has been traveling toward us for nearly that entire span of time. So you might expect the observable universe to be about 13.8 billion light-years across in any direction. But it isn't. Because space itself has been expanding this entire time, stretching the distance between us and everything else, even as their light travels toward us. By the time that ancient light finally reaches our telescopes, the objects that emitted it are no longer 13.8 billion light-years away. They are now roughly 46.5 billion light-years away, carried outward by the expansion of space itself. That gives us an observable universe approximately 93 billion light-years in diameter, a sphere with Earth, almost arbitrarily, at its center. Not because we are special, but because that is simply how far light has had time to travel to reach us, in every direction, since the beginning of time itself. Inside that sphere, an estimated 2 trillion galaxies, each one, on average, containing hundreds of billions of stars. The total number of stars in the observable universe is estimated to be somewhere around 1 septillion, a 1 followed by 24 zeros. More stars than there are grains of sand on every beach and desert on Earth, combined, multiplied many times over. And every single one of those 2 trillion galaxies, every star, every planet, every possibility of life we will ever observe, exists inside a sphere that represents only the part of the universe we are physically capable of seeing. This is the part that breaks most people's intuition completely. The observable universe is not the edge of the universe. It's simply the edge of what light has had time to reach us. Beyond that boundary, space almost certainly continues. We just have no way to ever receive light or any information at all from what lies there. Some researchers, analyzing the curvature of space, estimate the total universe could be at least 250 times larger than the observable universe, potentially over 7 trillion light-years across. Other models, based on cosmic inflation theory, suggest it could be unimaginably larger still, perhaps 10 to the power of 23 times the size of what we can see. And some physicists consider the possibility that space is infinite, stretching forever in every direction, with no edge at all. Here is the strange part. We will never know which of these is true. Because space is expanding faster than light can cross it, anything beyond our observable horizon is permanently, physically unreachable. Not just today, but forever. Not through faster spacecraft, not through better telescopes, not ever. It is the one place in existence that is, by definition, beyond all possible human discovery. And that means everything we've shown you in this video, every galaxy, every star, every grain of cosmic sand, represents, at most, an infinitesimally small fraction of everything that actually exists. So let's go back to where we started. A mountain, an ocean, a single human life on a single small planet, orbiting a perfectly ordinary star in the outer suburbs of one galaxy among 2 trillion, inside a sphere that represents only a tiny, knowable fraction of everything that may exist. It would be easy to find that thought frightening, but consider this instead. Out of all that vastness, out of 100 septillion stars and unimaginable trillions of planets, you exist right now, conscious enough to understand the scale of your own existence. Matter that came from the death of ancient stars has organized itself against every probability into something capable of looking up and asking how big the universe really is. That isn't insignificance. That's the rarest, strangest thing the cosmos has ever produced. And it happened here, on this one small, blue, impossibly lucky planet.